Combination of functions, composite functions. So we have a combination of them. We're going to do the sum of f plus g. So what we're going to do is we're going to take the f function and we're going to add the g function to it. Well, when I distribute that positive sign, it doesn't change the sign inside here, so it's just x squared plus 4 plus the square root of 1 minus x. And that is my final answer because there is no like terms to combine. If I do the difference, which is f minus g, and we can flip the order. It could have been, I could have asked for g minus f. Either way. But in this case, I said f minus g, so I take my f function, and we're going to subtract my g function. And you notice I put it in parentheses because the sign out here may change everything inside here, but since that's the square root, the only thing we're changing is the sign in front of it. And that's a positive square root, so negative times positive is negative. And now let's find the product of it, of f times g. Well, my f function, x squared plus 4 times the square root of 1 minus x. So what we're going to do is distribute. It gives me x squared, square root of 1 minus x, plus 4 square root of 1 minus x. Cannot combine these terms because there's no like terms, so that's my final answer. One more, let's do the quotient. So that's f divides g. So I got x squared plus 4 over square root of 1 minus x. And that would be my final answer because it will not reduce. Everything has to reduce because that plus sign says you can't separate the x squared and the 4. And just for a moment, I want to talk about domains. If I was to talk about a domain of this particular function here, we cannot have certain things in the denominator, and one is a 0 and the other is a root. So what we're going to do is see whatever is going to cause this here to be an undefined quotient. And whatever that is, then that will determine how my domain will be set up. So what we do is we see that we have an even root. And anytime you have an even root, we're going to take whatever's inside, set it greater than or equal to 0. And then we're going to solve. Well, in this case, it's easier to add the x to both sides because x is negative, and that says 1 is greater than or equal to x. But some of you are used to reading where the x is on the other side, so I'm just going to rewrite it one time. But be careful. Make sure that that you set it up correctly. That small point is pointed toward the x. That's how it should be. So now when I read this and I draw it on a number line, I'm going to put 1 here. And it says x is all numbers smaller than 1. So we're going to go in this direction, right? Go to negative infinity. And it's got the equal to sign, so 1 can be equal to it. That means I can plug in 1 here. 1 minus 1 gives me 0. And the square root of 0 is 0. Square root of 1 is 1. So we're safe. So my domain here is going to be negative infinity to 1 bracket, meaning I can include 1. So that means any points I use here, I can get a true answer here. But remember, I said we can't have 0 in our denominator. So we're going to, well, this would not technically be a true statement, because if it was, if I used 1 and included, I get 0 here, I get an undefined fraction. So we're going to say, cannot use this one. We have to rewrite it to where 1 is not included, so that's why we use a parenthesis. So this is the correct domain for this problem. Here, when we read this domain, I notice that any number I plug in for x is going to yield a real number, so it's all real numbers, right? Negative infinity, positive infinity. We already solved for that one here. Down here, we noticed that the domain for this one here is negative infinity to 1, because we can get a square root of 0, but if you notice when we plug it in here, we can't use that. So when we go check out all of our answers here, we notice my domains are going to be this here for every one of these, because we can't have a negative number inside of a positive, even, or not so much positive, but an even root, because we cannot multiply something an even amount of times and get a negative answer. If this was an odd root, then we could have a negative answer. We just can't yield 0 because it's in the denominator.